Oops. Okay, so the full border adjustment. Okay, so in the full border adjustment case, what we have is we rebate exports. So that is to say, you don't have, so you reduce the price by the amount of taxes you would have to pay. Okay, so that's why you have a lower price for exports compared to the case without export rebates. And then you tax imports. Okay, you tax imports. And the reason is that because at home you're still paying a higher price. Okay. So what you would like to do is, by taxing imports, you would like to have to level the playing field for firms at home, and by rebating exports, you would like to level the playing field for firms at home, abroad. Okay. So let me repeat this. So export rebates and import taxes. With the import taxes, you would like to level the playing field at home, because at home firms, for the home market, firms have to pay taxes. So that's why you want to correct import prices such that the playing field is the same, okay, for firms, home firms and foreign firms at home. But then in order to level the playing field abroad, what you do is you give a rebate to the firms exporting. Okay, so in this, still what they have is they have higher costs. So still they have higher costs, okay, here. Because since the tax is in place, firms change their behavior, and in particular, they switch to more costly technologies which are greener, okay, because they try to reduce emissions. And that's why they have higher costs. Okay, so and that's exactly what you would like to do. Okay, but what you would like to do is you would level somehow the playing field. So you will try to not punish your firms. Okay, so in the home market and in the foreign market. Okay. There was a question about sharing. Yes, sorry, I'm not recording lectures. Okay, so I just recorded lecture last week because there was a special request, but usually I'm not going to record. There are several reasons. I don't want to go into all these reasons, but there are several. That's why I'm not going to record. So you have, for those of you who are not, so you have want to do something else, okay, they can still look at papers, books, and slides, okay. But I'm not going to record lectures, okay. Only if there is a special reason for doing so, like there was some students attending some conference or whatever, and were not able to attend lecture, and that's why I recorded lectures. But otherwise, I'm not going to record lectures. Sorry. Okay. The one I shared, the one I recorded last week, I posted the link on Virtuale. Okay. Any other questions? Okay, so yesterday, okay, I was kind of running out of time, and that's why I was really sloppy in discussing the results, which perhaps is kind of a pity. So still, I mean, if you're interested in methodology and further results, still worth reading the paper, at least the introduction, conclusion, and try to figure out what's going on. The only thing I was trying to make yesterday, but it made it wrongly, okay, because the data I should have really discussed were about Europe, because then I'm going to discuss later on today. The proposer is what happens if you have the import tax for Europe. Okay, so the simulations for Europe are particularly interesting, at least for us Europeans, okay, let's say. And here you can see is what I I mean, as I said yesterday wrongly, okay, it's correct for Europe. And you see the import tax in Europe, which is here the first column here, works quite fine, okay, in avoiding production losses. So there will be here this column. Okay, they work quite fine. Okay, you see, and it's the simplest thing to implement. Okay. And here, for foreign carbon intensities, it works better than home carbon intensity. And it's true also for, if you look at the net export loss avoided, okay, also in this case, the import tax works fine. Okay. Okay, this is something just that I wanted to highlight. Okay, so, and I'm going to back to this in a minute. But before doing so, I would, if there are no other questions, I would like to talk about another empirical paper, and that's about the EU emission trading system and carbon leakages. There's a recent paper published in the Journal of Environmental Economics and Management in 2019 that investigates whether the EU emission trading system causes carbon leakage in the European manufacturing sector. Okay, here what the authors, again, I won't go into all the details of the paper. I just try to give you an idea of what the authors do, okay, and what the results are. So first of all, the first thing is the stringency of how to measure the stringency of environmental policy. The stringency is calculated taking direct and indirect costs of emissions into account. In particular, the indirect costs are calculated through an input-output analysis. Okay, so therefore, not only direct costs, but also indirect costs of environmental policies are taken into account here. And also what the authors do is they take free allowances into account. So remember when I explained the very beginning of the EU emission trading system, if you are not familiar with it, okay, over the time and still nowadays, there are many free allowances, okay, because of the trade exposed, highly trade exposed industries. Okay, so there would be an estimated loss in competitiveness, and that's why the emission intensive and trade exposed industries are granted free allowances still nowadays. So therefore, what the authors do is, if stringency of test whether stringency of environmental policy affected net exports, net imports, and both value or in embodied carbon of the EU from a given sector or of a given country in the year. And therefore, net exports are a difference between imports and exports. And therefore, what they do is they look at bilateral trade flow, again, in value and in embodied carbon from one country to another in a given year and the sector. So that would be a two-way inter-industry trade with the bilateral trade flows. That's the two things the authors look at over the time period 2004 and 2011. Okay, so let's see, first of all, some results and then some further insights that might be useful in order to understand these results. So what the changes in trade flow consider are two channels of leakage. One is production relocation away from the EU, and the other is the loss of EU firms in the market share. And Therefore, what here, as I already mentioned, okay, so direct and indirect costs. The indirect costs are mainly electricity use. Okay, so these are the main indirect costs. Okay, and then what they do is they regress the trade flows on emission costs. Okay, so first of all, establish emission costs, direct and indirect, and then see how emission costs affect trade flows. Okay, this is how the analysis is done. And the result is the following. So the result is that the authors do not find evidence of carbon leakage. Okay, there is no evidence for carbon leakage. Now let me explain why. Okay, this is the conclusion of the authors. Okay, so again, one might debate. Okay, there are several things one has to take into account. But let's see what the author's explanation here is for this result. The explanation is the following: that the additional costs of the emission trading is very small. Okay, this is very small compared to other costs, and in particular compared to labor costs, because labor costs are 10 to 30 times higher than in emerging countries. Okay, so and emission costs here imposed by the trading system is below 0.65 of total material costs for almost all of the manufacturing sectors. Okay, that's why you see the impact of these costs is very, very small. Okay. And so this is the first. So by estimating the direct and indirect costs of emissions, okay, the authors conclude that they are very small. And since they are very small, the impact is very small, and therefore they do not, I mean, according to the authors, regression results, okay, there is no evidence for carbon leakage. And then they also argued that relocation of production activity is risky and costly. Okay, it's risky and costly, and that's why firms might be not inclined to do so. Okay, so they might prefer to stay at home, okay, rather than shifting production abroad. And moreover, if you read the paper, okay, claim of the paper is that, according to their calculus, okay, is that some industries, some sectors received a net subsidy from the EU emission trading system. Remember, because of the free allowances. Okay, so there were no real costs, but instead, quite the opposite happened. Okay, they received free allowances rather than. Sorry, they received a subsidy rather than cost. Okay. And that's why. Given if you take into account both costs and subsidies, that is free allowances and so on and so forth, overall, okay, the effect was nil, and therefore the impact on carbon leakage was therefore negligible. And moreover, the Porter hypothesis also might work in the sense that if you have tighter environmental policy, this might lead to innovation, okay, and therefore a reduction of production costs. Okay. And that's why you don't carbon leakage does not show up in the data. Okay. Therefore, also the Porter hypothesis might here be it might play an important role for the result. Okay, so. Still, also remember here again, another problem I might say is that the time period considered is 2004, 2011, and remember there the price of emission was very low, okay, even though the spot price was high. Okay, it's something we already discussed by looking at another paper. Okay, for the price. Okay, so this might also be clearly a problem. Okay. And that's why, okay, taking the data, okay, might also be a problem of how things have been done. Okay? So it's coming back to a comment of student not here today. Okay. Again, okay, I mean, it's an interesting paper. One might be interested in looking it up, and but it might also be interesting to redo the same analysis, perhaps for another time period. Okay? Because again, the time period chosen was not particularly ideal. Okay? Because remember, price was very low. Okay? First at the beginning because of excess supply of allowances, and then also because of the financial crisis 2008, which also lead to a collapse of the price for certificates and so on. That's why, okay, there are problems for sure with the time period considered. So let's now, what I would like to do is now I would like to shift to policies that are in place or are going to be in place. Okay, in particular, as I already mentioned, I would like to talk about two things. So one is the EU border adjustment mechanism that has been, this is a proposal yet. Okay, this is a proposal. And this is the draft in from July 2021, okay, so quite recent. And what I'm going to do first, I'm going to explain what the EU would like to do in the upcoming years, okay, dealing again with the problem of carbon leakage, because this is a policy, okay, aimed at equalizing the price of carbon between domestic products and imports. Okay, so meaning countries that are not, so we are importing products from abroad where these countries do not face carbon taxes or an emission trading system like EU producers face, and therefore what the EU here wants to do is wants to level the playing field, okay, with a kind of import tax. And that's why the figures I tried to highlight before at the beginning of this lecture was quite important. Okay, so let me briefly, and this is the proposal. I just want to show you what the proposal wants to do, and then I'm going to discuss a similar example that is already in place, okay? From which perhaps we can learn something. Okay, so how does it work, or how should it work? Okay, this is a tax on greenhouse gas emissions. So it should be a tax on greenhouse gas emissions during the production process of products covered. And what therefore EU importers should do is they should buy certificates. Okay, they should buy therefore carbon certificates corresponding to the price of carbon that should have been paid had the goods been produced under the EU carbon pricing rules. Okay, so really, here the intention of the EU is to level the playing field. Okay, so and therefore, what the non-EU producers can show is that they already paid carbon taxes at home, and therefore, if they paid carbon taxes similar to the EU one, then they are exempted. Okay, so they have to pay, they have to buy certificates only if they are unable to show that they already paid the price for CO2 emissions at home. Okay, is it clear? So they would like to. So the EU here would like to avoid double taxes. Okay, so if you have already paid taxes abroad, so you should not. I mean, you're not required to pay them again at home. Sorry, at home in the EU. Okay, so if you pay taxes abroad, you're not required to pay them again in the EU. Okay, and therefore this carbon border adjustment mechanism should really mirror the EU emission trading system, and therefore the price of these certificates, okay, should correspond to the EU emission trading system allowances. Okay. So what are the sectors covered? The sectors are high risk of carbon leakage sectors and therefore high carbon emissions. So initially should be cement, iron and steel, aluminium, electricity, okay, again, which plays a crucial role, fertilizers, and so on and so forth. Okay, so these are the main, main polluters, okay, heavy polluters here, high carbon intensity. Sectors. Implementation is also something I already discussed, I mentioned. There should be a gradual phase in because 2023 to 2023 and 25, so for the upcoming years, what the EU would like to do is just gather information, learning how, and therefore gather information that should then, starting with 26, should then be used in order to tax imports accordingly. Okay, so it's just transitional period in order to collect data on carbon emissions. And then financial adjustment payments should be paid starting 26. Okay, so the system should really start in 26. And correspondingly, starting also with 26, the free allowances should be reduced. Okay, because remember, all these industries, nowadays get free allowances because of the fear of carbon leakage. So therefore, once this carbon border adjustment mechanism kicks in, the EU the intention is to reduce free allowances. Clearly, because you're not going to tax imports, but give free allowances to home producers. It would not make sense. We would really like to level the playing field. And free allowances they are expected to phase out in 35. And therefore, importers should be treated the same as EU producers. Okay, that's the intention, okay, of this proposal. Yeah, that's just the detail, because clearly here the issue, I don't want to talk too much about it, but it's clearly interesting. The issue, it goes back also to the figure I showed you before. And so how to determine the carbon content or the emissions of products imported. Okay, this is clearly a problem. Okay, it's not obvious to do this. And so the plan is, that's why there is this learning period for the 2 years, 23, 25, where they expect to gather information that should then be useful for the later periods. And well, the information should be communicated to importers, okay, by the non-EU producers. So first of all, by the non-EU producers, and then if not available, there should be default values, okay, on CO2 emissions. And this clearly is needed in order to determine the number of certificates that have to be purchased. And then there should also be a conciliation procedure. Okay, should there be a mismatch? Okay, this is the proposal. Is it clear? Now, in order to see how this, in order to have some information more, okay, about what's the likely outcome, okay, there is an interesting case, okay, already in place, even though it's kind of small, but it's still interesting, okay, because California, which is kind of peculiar, okay, let's say, the case, because California has a cap and trade system in place, okay, now quite a long time. And what they also have is they have a carbon border adjustment system in place as well. Okay. And in particular, what is covered is the electricity sector, because again, if you're interested in all the details and if you want to know a little bit more about California, okay, this is a very short paper published in the American Economic Review Papers and Proceedings. It's just a couple of papers. A couple of pages, okay, and so it's very, very it's very informative about the system, okay, and here, yes, the authors argue and they show, okay, that The electricity sector, why the focus on electricity sector? Because the electricity sector was crucial in order to meet emission targets. Okay, that's why the sector covered by the system, by the California system, is mainly the electricity sector, because it was crucial to meet emission targets, which have already been met past years. Okay, so and that's why they have a border adjustment system for electricity. Okay, and that's what the authors discuss in the paper, and therefore imports of electricity are subject to differentiated border carbon adjustment mechanism. The aim is clearly again to avoid leakage. Okay. So what the aim here is, so you have the idea is you have a cap and trade system in place, okay, in California for emissions. So what the authors, what the policymaker wants to avoid clearly is that, given that there are costs on emissions in California, that the industry just moves outside of California, and then that you import the dirty goods, so that you have overall the same emissions. Okay, this is carbon leakage. Okay. Only that this is a regional system rather than a national system. Okay, because you have just a regional system for California. Okay, and the border carbon adjustment mechanism is a differentiated one, depending on the intensity, emission intensity of imports. Okay, so you can have different emission intensities for different products that are imported, and according to these different emission intensities, you have different taxes. Okay, this is how the system works. Okay, this is the paper. It's a very recent paper, 2001, American Economic Association papers and proceedings. Okay, so just a couple of very short paper, but very very interesting for the case we're studying here. Okay, so the aim of the paper, as I mentioned, is investigate the effectiveness of the border carbon adjustment mechanism. I hope it is clear what the system tries to do. Okay, the paper studies, and I mean the result is obtained through simulating. Okay, so simulations. Okay, and the authors conclude that the differentiated border carbon adjustment mechanism has no moderating impact on greenhouse gas leakage. Okay, so that the system is very ineffective. Okay, it doesn't work, okay, according to the authors' calculus. Okay, and the intuition is the following. Okay, the intuition is quite straightforward. So out of the reason is that even if California has this carbon border adjustment system in place, what happens is that production, I mean, which is cost in California, moves to another region where there are no such costs in place, and then what you do is you preferentially import electricity. Okay, depending on the emission intensity. Since it's costly to import, what you do is you import these products that are that have low emissions, and so you don't have to pay costs. Okay, but in the other products are just supplied to other regions where no such a system is in place. And so overall, the authors conclude you have no impact on the system-wide carbon footprint. Okay, is it clear? It's quite intuitive. Okay, so you have that production is taxed at home, and therefore production is placed outside. But then, since you have a border adjustment system in place, what you do is you import the product with the lowest emissions. And the one with the highest emissions are just exported to some other regions. Okay, so you have a preferential trade system in place. Okay, so you export the dirty goods to regions where no taxes are in place, and you export to California products that have low emissions, so you don't have to pay taxes. Okay, it's just a way to play the system. Okay? Is it clear? This clearly can be done because the system it's just a regional system. Now, if this will also apply to the EU, which is quite large, okay, is something that we will see. Okay, but it's quite interesting to see this. Okay. Is it clear? Okay, so if there are no questions, okay, so we have a very short description. I would like now to perhaps skip this. This is perhaps not that interesting. I already talked about this. I would like to switch now to the next argument. That's next topic. Sorry, and it's gonna be. I'm going to talk now about trade and the environment. Okay, so in particular, here the main focus will be how trade affects welfare on the one side, and that's something we are going to see from a theoretical point of view, and then what we're going to study from an empirical point of view. I'm going to discuss several papers, is how environmental policy affects trade flows. Okay. Which is somehow related to the problem of carbon leakage, but the carbon leakage problem is just a problem of CO2 emissions disappearing somewhere but appearing somewhere else. Okay, while there's a more general problem of how environmental regulation, which concerns not only CO2 emissions but also other pollutants. Okay. How environmental regulation affects trade flows, and that's something I'll discuss. I'll discuss at the end of this lecture. Okay, this part of the lectures. Okay, so therefore, what we're going to see here is first of all, extend Heckscher-Ohlin theory, trade theory, accounting explicitly for environmental resources. Okay, so I'm going to do this formally here, because what I would like to do is therefore account formally for the gains from trade. I'm going to show you how this emerges from a mathematical point of view. If we look at a formal description of the economy, and then also considering the impact of trade on the environment, okay, and therefore how the environment affects welfare. Okay, before doing this is going to be important also for the empirical papers I'm going to discuss, because this is how you can investigate things from an empirical point of view. So to decompose the effects of policy on emissions, okay, in particular, and here the framework is the following. Okay, so suppose now, so this is the same as we have seen in the previous lectures. And so suppose now we have two goods, so Y and Z. So remember, Y is the capital intensive, Z is the labor intensive. So Y is the dirty good, okay, and labor intensive is the clean good. Okay, it's just by assumption. Okay, it's not. For the moment being here, not particularly relevant. And then I'm going to define two things. So first of all, what the scale of the economy is. The scale of the economy is just the size of the economy, how large the economy is. And that is here given by, if you want, it's GDP, and it will be PZ, Z plus Y. Okay, this is the scale of the economy using prices in the base year. Okay, because you would like to eliminate the price effect, okay, over time. You would like just to consider the scale of the economy. If the economy gets larger in terms of units of output produced, okay, from the two sectors. Okay, so you have to consider. I mean, you can't sum up simply the quantities because you can't sum apples and bananas or whatever. Okay, that's why you have to consider the value. Okay. But what you do not want to take into account is how price changes over time affects here our measure, because clearly I just want to capture the scale of the economy. So if the economy gets bigger in terms of number of output produced, okay, not in terms of prices, because clearly they do not affect the scale. Is it clear? This is therefore, I'm keeping prices constant. Okay? Just consider the number of output. Given this, I can define what pollution is. Pollution is emissions times the quantity of the polluting quantity of output produced in the polluting sector. Okay, that would be here my Y. Okay, Y is the output in the polluting industry, and therefore E, which is the emission intensity. E is emission intensity times Y is pollution. Okay, and therefore, so this is a definition, and therefore, given the definition of the share of the polluting industry in the economy, which is my phi Y, I can rewrite pollution in terms of E times phi Y times S. I think it's quite obvious, okay, how this is. Is it clear? So now you see I have my emissions here, so pollution, okay, which is given by 3 components. So it would be E, which is the emission intensity, phi, which is the size of the polluting industry as a proportion of the economy, and then the scale of the economy. Okay, so I have 3 components: E, emission intensity, the proportion of the polluting sector in our economy, and then the size of the economy. And therefore, these are the 3 components that here play a role. So E are emission intensity, composition, and scale. Okay, so that's why I have now decomposed here emissions into pollution into 3 factors. Emission intensity, which is E. Emission intensity depends on the technique, okay, employed. Okay, so emission intensity depends on the technique employed. Now, phi is the importance of the dirty good industry in the economy, and therefore it depends on how large the dirty industry is, and scale is how large the industry, how large our economy is. I'm going to discuss this in a minute. Okay, so why these 3 might be important, how they change. Okay, so but before doing this, what you are really interested in is the growth rate of pollution. Now, in order to obtain growth rates, I don't know how familiar you are with this. Let me do this just once, okay? So what you do is you take, I mean, all these variables, they depend on time, okay? So they can change over time, okay? So therefore, what you do is you take logs and then you take time derivative, okay? So suppose, let me do this, let's see. So consider xt and yt, okay? And you want to know what the rate of change over time is. Okay, so how this changes over time. Okay, so the time derivative. Okay, so what you can do is you can do the following. Okay, so first of all, take logs You take logs, because in this case, this is going to be log x plus log y. Okay, and then you take just the derivative of this with respect to time, and that's why this is 1 over x times the time derivative. That would be dx over dt plus 1 over y dy over. Okay, is it clear what I've been doing here? Okay, so the simplest thing, again, let me repeat this, is first of all take logs and then take the derivative, the time derivative. Okay, this is usually, I mean, this is, you can write this as the rate of change, okay? Clearly what you mean here is of time, okay? This is how it is, how it can be written in a more simple way, okay? And this is what's done here, okay? So you take logs, first of all, if you take logs, so the log of D is just the log of E plus the log of phi plus the log of S, and then you take time derivatives, okay? And therefore it's just 1 over the argument times the derivative of the argument, okay? And therefore it's just 1 over E times the time derivative of phi plus 1 over phi times the time derivative of phi plus 1 over S times the time derivative of S. And that's how you get this expression here. Is it clear? It's just a refresher here, I think, nothing special. Now, this tells you the following. So how does growth change? Sorry, how does pollution change today? How does pollution change? Well, it depends on the technique effect. So the technique effect is E over E. So how technique changes? We know that emission intensity might change because of environmental policy. So you have a carbon tax in place, and therefore firms may switch to less polluting production technique. Okay, and this changes clearly the emission intensity. Or you could have a change in the composition of the economy. Okay, you can have a change in the composition of the economy. Again, so this would be my phi, my phi y over phi y. So how what could here be the driver? An emission tax at home can move production of polluting products, highly polluting products abroad. And therefore what you have is you have the share of the dirty industry in our country declines. Okay? This would be a composition effect. Okay, this is exactly what we have seen with extra oil. Okay, like extra oil case. Okay, you have a tax at home, and this changes the composition of our economy. So phi y declines, and then you have a scale effect. Last but not least, you can have a scale effect. There will be ds over s. The scale effect is due to simply a growth effect, in the sense that if the economy grows, then without changing its composition, so more output is produced in keeping the proportion of the sector constant, then clearly you have more pollution, okay, simply because of growth. Okay. And so therefore you can have theoretically all these three effects. Okay, indeed, perhaps, I don't know, next week, most likely I'm going to discuss empirical papers and I try to estimate these three effects. Okay, so how environmental for instance, how environmental regulation affects pollution by looking exactly at technique effects, composition effects, and scale effects. Okay, but before doing this, some further results. Okay, in particular, I would like to briefly talk about the environmental goodness curve, which for sure you have already heard about, and perhaps you have also seen some data and done some estimation on your own. Okay, so the environmental goodness curve is an inverse U relationship between indicators of environmental degradation and income per capita. Okay, so usually, what this is a hypothesis that then you try to test. Okay, you bring it to the data, and what therefore is here the expected result is that for if you have low income countries, then environmental degradation is low, but then as income increases, environmental degradation increases, and then later stages, environmental degradation should go down. Okay, this should lead to this environmental goodness curve. So instead of going into the details, okay, there is okay. So let me first of all discuss the theoretical reasons why you might expect an inverted U relationship. So the first story is relates to what we have seen in the previous lecture. So it is going back to the Rybczynski theorem we have seen yesterday, and that is because of growth sources in the economy. And that is to say, if a country is in an early stage, okay, so it's a less developed country, then usually growth, of course, through accumulation of physical capital. Okay, so this is known as a process of industrialization. Okay, so you start to accumulate physical capital and then and therefore produce output using more and more physical capital, and therefore what you have here is because in this way what increases, I mean, you have an accumulation of physical capital. What therefore increases is the production according to the Rybczynski theorem we have seen. Okay, what should increase therefore is the production in the dirty good, and there should be a decline in the production of the clean good, and therefore this should increase pollution. Okay, so this should explain the first phases of the first stages of economic growth. Okay, so the first stages of economic growth should occur through, and here this is one explanation, through accumulation of physical capital and therefore production of more and more polluting goods. And therefore what you get is a positive relationship between income and pollution. So you have an increase, you observe growth and therefore increase in income, but at the same time also increase in pollution. In later stages, what one might observe is an increase in human capital rather than in physical capital. Because if you look again at the experience of industrialized countries, so developed countries, this is exactly what happened. Okay, in the early stages of their development, you have accumulation of physical capital, but then in later stages, physical capital plays a less important role compared with human capital. Okay, and therefore, what you have now in later stages of economic growth, you have accumulation of human capital rather than physical capital. Okay, so now growth in developed countries, okay, occurs through accumulation of human capital rather than physical capital. Now, the accumulation of human capital rather than physical capital, according to the Rybczynski theorem, should lead to an expansion of the economy, but in the direction of the clean good rather than the dirty good. And therefore, you see here, there is a change in the composition of the economy. Okay? And this now should lead, therefore, to a negative relationship between growth and therefore income and pollution. Okay, so now you have increase in income, but lower pollution. Okay, so the first story here, therefore, using the Rybczynski theorem, uses the idea of a change in the structure of the economy. Okay, so it's just a composition effect. Okay, so here, according to this theory, the Kuznets curve can be, the environmental Kuznets curve is explained because of a change in the structure of the economy and therefore a change in the composition of the economy. Therefore, just the composition effect. Okay, so again, in early stages, you have accumulation of physical capital and therefore pollution, and therefore increase in income is driven by accumulation of physical capital, and therefore more pollution, and then later stages, human capital becomes more important than physical capital, and therefore you have increasing income but lower emissions. And this is in kind of in keeping with some anecdotal evidence. Okay, if you look at countries, okay, some countries in particular. But there are many other ways to get these inverted U-shaped relationships. Okay, so the first story, okay, yes, what I just said. Okay, sources of economic growth. Okay, this is what I just explained. Okay, accumulation of physical capital in early stages and human capital in later stages. But then there are also other theories in addition to these income effects. Okay, so changes in demand for environmental quality as income rises. Okay, so if you are very poor, if you are a poor country, then you're only worried about bringing food to the table rather than care about the environment. But then the richer you get, the better gets your taste for environmental quality. Okay, so you're more worried about environmental quality. Okay, this on the one side, but also on the other side, in particular, if you're richer, if you're getting richer, you're no longer worried about bringing food to the table, but you're getting worried about growth potentials. Okay, this is the case of China, for instance. Okay, so in China, the environmental problem got more and more severe over the recent decades, okay? And that's why they changed their policy towards environment because of health problems. Okay, so the air is still very, very polluted, and that's why they changed their because of health costs. Okay, not only health costs, but also, I mean, if you have polluted air, clearly this decreases the value of human capital. Okay? And since economic growth nowadays is mainly driven by the value of human capital, okay, what the country should do, this is also true for developing countries. Okay? What the country should do is should try to maximize the value of human capital. Okay? Clearly now, if you have a very polluted environment, this decreases the value of human capital. Okay? And if you have a lower value of human capital, what individuals then do is they invest less in education, and therefore what you have is you have lower growth. Okay? And that's why it's not only I would like to change this claim here. It's not just that I mean, this is true for many countries. It's not just that as income increases, you develop a taste for the environment, but the environment can also become a hurdle to growth. Okay, so so this is the case of China, for instance. Okay, so having a very polluted environment can lead to hurdles to growth. Okay, so because remember, if the environment is very polluted, then you have a lower value. Okay, the value of human capital is lower, okay? And having a lower value of human capital means that individuals invest less in education and so on. Okay? That's why what policymakers try to do is they try to maximize the value of human capital, because this stimulates growth. Okay, is it clear? Yeah, one concrete example is quite obvious, is the environment effects. This is also true. In particular, there are many studies for developing countries, that confirm this. If you look at indoor pollution, in many developing countries, a major problem is not so much outdoor pollution, but rather indoor pollution. And indoor pollution depends on the energy sources used for cooking. Okay, and what happens is that many developing countries, because they are so poor, they have severe problem of indoor pollution, and this leads to a high rate of infant mortality, and that's why this clearly decreases longevity, and therefore decreases the value of human capital. And this confirms what I said before. This is one of the major hurdles, for instance, for growth in developing countries. This is one story, but there are also others. Threshold effects. So pollution is tolerated as long as it remains below a certain threshold, and then once it's larger, then you start engaging in activities aimed at reducing emissions. And then what you can also have is increasing returns to abatement. Okay, so meaning that at the very beginning, abatement costs are very high because technologies are very new, and therefore they are high. But then the more and more you invest in abatement technologies, the more efficient you get, right? In producing such technologies, and therefore it gets easier to abate, and this is another way to get the inverted U relationship. So at the beginning it's very costly, that's why you grow, and you still have higher income but higher pollution. But then because of increasing returns to scale, it becomes easier and easier to reduce emissions, and that's why you're going to do so, and that's why you get a larger income but declining pollution. Okay. Now I'm not going over empirics. You might have seen some of this perhaps in the applied econometrics course, because estimated environmental goodness curves are very sensitive to the sample used, and the problem is, and also not only the sample used, but also the technique used in estimating environmental goodness curve. There is a review paper. There are many review papers. One is by Stern, and you can have a look where the results are reviewed. Okay, now what I would like to do here is consider trade liberalization and environment. So what I would like now to do is I would like to study the effects of so this is really an extension of what we have seen in the previous lectures. What I would like to do is see how trade liberalization affects welfare through both channels. One, the standard gains from trade channel, and the other through the environment, polluting or non-polluting the environment. Okay, so that's why here I would like to consider both of these effects, and therefore let me go very fast over this. The intuition, okay, the setup of the model, and then the result of the model, and then we take a break. And after the break, I'm going over the mathematics, okay, to show you how this can be done from a formal point of view. Okay, so here what I would like to do is the following. Okay, so build a very simple model, so the simplest possible, to study how a change in the trade regime affects the welfare of an economy. Okay? Considering both, on the one side, gains from trade, this is what we have already seen. Okay? In the first part, we have seen that opening up to trade increases the consumption possibilities and therefore increases welfare, it increases also income. These are known as gains from trade. And here I'm going to show you in a model, a formal model, how this happens. But then secondly, what we have not considered, there might also be a second effect, and that is the change in the composition of in the economy might lead to more pollution and therefore a negative effect on welfare. This second effect, so the negative effect of pollution because of exports more exports in the dirty sector, this can or cannot offset this higher pollution can offset or not the gains from trade effect. Okay, and therefore we're going to see that the extent of how pollution affects welfare will depend on the policy in place. Okay, that's why the economic policy will play a crucial role. And we are going to see how to deal with it. That motivates also. I mean, here we are going to consider environmental regulation. That's why I had the very first lectures about environmental regulation. Because here we're going to see environmental regulation in place. First from a theoretical point of view. Okay. So let me give you here just a peek into what we're going to see and the results, because the intuition of the result we're going to see is very simple, and the formal model is a little bit more complicated. Okay, so how do we model this? Okay, the model is the simplest as possible. So it's going to be an so those of you familiar with trade theory will have heard of this type of model. Okay, so this is going to be an iceberg model of trade. So meaning that shipping goods from one country to another country is like shipping an iceberg. Okay, meaning that over time the iceberg melts, or ice melts. Okay, and therefore to deliver one unit, you have to ship 1 plus delta units. This is here how trade frictions are modeled. Okay, so this is therefore the iceberg model of trade costs. Okay, so let me repeat this. Okay, so in order to deliver one unit, you have to ship 1 plus delta, because delta is the amount of the size of the good that disappears, okay, during the shipment. So it's kind of a way to model transportation costs, a reduced form. Now, P is the world price, and therefore you have both a domestic and domestic price for the importing country and domestic price for the exporting country. So domestic price for the importing country is PM. Domestic price for the importing country is PM, and here PM is P plus 1 plus delta, so it's larger than P because of frictions. Because of frictions, you pay more than the world price. Okay, this is for the importing country. Okay? Because of these frictions, you pay more than the world price. The domestic price for the exporting country is PE, which is P over 1 plus delta. which is lower than the world price. That is to say that the exporting country gets less than the world price because of these frictions. Okay, is it clear the effect of frictions on prices? Okay, so meaning these transportation costs here lead to a wedge in the price of what the exporting country gets and what the importing country has to pay. Okay, the importing country has to pay a larger price, and the exporting country gets a lower price because of these frictions. So this is important in order to understand the results we're going to see, because here we are going to study trade liberalization by reducing trade frictions. So that would be reducing delta. We're going to study trade liberalization by reducing delta, which are the frictions. Now, what does this lead to? This leads for the importing country to a decline in the price. Okay, so PM goes down, but on the other side, for the exporting country, the price increases. PE goes down, goes up. So this is the effect of reducing trade frictions. Now, let me, as promised, let me give you in 5 minutes, okay, then 5-10 minutes, the result, and then I'm going to take a break. Okay, here we're going to study two scenarios. One is permissions. Okay, let me perhaps here. Yeah, okay. One is permissions, so permits, sorry. Fixed emission permits. Okay, so it will be the emission trading system. So we're going to study here two cases. One is emission trading system, and two is taxes. And we're going to study these two cases. Taxes, a particular type of taxes, tax that keeps emission intensity constant. Okay, so the tax is aimed at keeping emission intensity constant. Okay, this is what the paper does. Okay. That is taxes that, by assumption, keep emission intensity constant. Okay, so now let's see what the results are, because the results are quite intuitive. Okay, now consider first of all here permits. Now here it is assumed that changing trade regime does not change the number of permits that you have. So if you, for instance, you reduce delta, this does not change the quotas. Okay, so it does not change the overall amount of or number of certificates, okay, that are available in the economy. Okay, so what is the result here? You have to distinguish two cases. So consider first the case of a country that imports the dirty good. Okay. If the country imports the dirty good, it means that it has a comparative advantage in the production of the clean good. Okay. Now remember what the reduction in delta leads to. The reduction in the trade frictions leads to an increase for the price for the exporter and a decline M for the importers. Okay, P is the price of Y, the dirty good. Okay, because the other good is the price of the other one is normalized to 1, and it's not relevant. You can always normalize one price. Remember, because in economics, what matters is only the relative price. Okay, so here that's why we focus on the price of the dirty good rather than the clean, because it's clearly more interesting. So now let me repeat this. Okay, if you import Y, it means that you have a competitive advantage in the production of the clean good. Now, if there's a reduction in delta, you see for the importer, the price goes down. So meaning what? That for the importer, you're going to even produce less of Y. Okay, so this means that you're going to produce fewer units of Y and increase the production of Z. But this means that pollution goes down. Okay? But permits here are fixed. So the overall level of emissions is fixed. Let's say the upper bar. This means that now you have an excess supply of permits. So you have an excess supply of permits. And therefore, the price of permits declines. The price of permit declines. And this clearly now changes the production technique for producers, because now producers are going to switch to dirtier techniques. So producers, as a consequence, switch to dirtier production techniques. And therefore, on the one side, okay, therefore, as a consequence here above, you have emission intensity, E, okay, yeah, it's not really, okay, emission intensity, these are emission intensity goes up. And as a consequence, overall pollution remains the same. And what happens here is that the technique effect, this second effect here, completely offsets the composition effect here. And so overall emissions remain the same. Is it clear? The overall emissions remain the same. This is because the technique effect completely offsets the composition effect. Okay. For the exporter, it's just the same. Okay. Let me perhaps very briefly repeat it. Okay. So remember, for the exporter, what happens is the price of exports increases, and therefore the exporter increases production of the dirty good and decreases production of the clean good, and that's why pollution in this case goes up. But now you have an excess demand. You have an excess demand of permits. Okay, so you have that D now is larger than D upper bar. You have an excess demand, and therefore price of permits increases. But if the price of permits increases, it becomes costlier to pollute, and that's why what to do is you have to switch to cleaner production techniques. And so emission intensity goes down. And this happens till the pollution is equal to the number of permits available. And so again, the technique effect completely offsets the composition effect. So no effect of a change in trade regime on pollution. So what you have in this case, you have only positive gains from trade effect. Okay, so if you look at the welfare here in this case, you do not have an impact of the environment on welfare because the technique effect offsets the composition effect. So you have only the gains from trade effect. Okay. Second result, and then I'm going to stop, is what happens if you have a tax with fixed emission intensity. Okay, so you have a tax such that the emission intensity is kept constant. Now you have a slightly different result. And okay, again, it depends on whether you are importing or exporting the dirty good. Now consider the importing good. Now remember, the importing good is paying a price larger than the world price. Okay, and therefore the price is going to decline as trade frictions decrease. Now in this case, again, you have two effects, okay, and they're going to be the following. Okay, so the first is so remember, this is going to be for the importing country. So you have that PM goes down, and therefore you have that for the importing country, Y goes down and Z goes up. And as a consequence, you have that pollution goes down. And therefore, in this case, you have what is called a double dividend. In this case, you have a double dividend because on the one side, you have positive gains from trade. And on the other, you have positive environmental effect because of a decline in emissions. Okay, so this country, in case of taxes, benefits most because it has a positive, trade liberalization increases welfare because of gains from trade, but also because of less polluted environment. Okay, less polluted environment. What happens for the country that exports? Why? In this case, remember, PE goes up, and therefore what you have is, according to what we have seen, okay, already, okay, but it's quite intuitive, and given all the stories I've told yesterday and the previous lectures. Okay, so you have Y increases and Z goes down. So that's the opposite. And since Y is the polluting good, you have that pollution goes up. And now you have an ambiguous effect. You have an ambiguous effect because on the one side you have, in terms of welfare, okay, on the one side you have the positive effect of trade. So these are the gains from trade. But on the other side, you have negative environmental effect. And so therefore, the overall effect is ambiguous. And what I'm going to show you after the break, where we're going to see the formal model, is that the overall outcome depends on environmental taxes. Okay. So how strong the negative environmental effect is depends on the size of taxes. Okay. In particular, if the taxes are set in a correct way, so shadowing exactly the cost of the environmental cost of pollution, then in terms of welfare clearly, then this second negative effect is eliminated. Okay, so if that is to say, if taxes are set in an optimal way, then you do not have a negative environmental effect. Okay. But if you are short of the optimum, then you will have the negative environmental effect. And clearly, the shorter you are, the larger is this effect, and therefore also the stronger the negative effect on welfare. And it might also happen that the negative effect on the environment are larger than the gains from trade effect. So that overall the country is worse off rather than better off by opening up the trade. Okay. So this is the intuition, and for the exam, okay, should there be a question like this? Okay, discussion like this is fine. I'm going to now, we're going to take a break, but after the break, I'm going to show you how this can be modeled in a formal way, and to give you just a very, I mean, because the final result is very simple, okay, but getting there is a little bit more involved. Okay, so I'd like to take a half an hour break, and for those of you who are interested, let's meet again after the break, okay, where I'm going to show you the formal one. Okay, have a nice lunch break and talk to you later if you want. Bye-bye. Hmm. Okay, let's start. Okay, I have to switch on. Okay, let's see. Okay. Okay, now this is going to be quite a technical lecture because I think on the one side, I think it's useful for those of you who have never seen economics from a foreign point of view and perhaps are interested in doing some further studies in economics, because at least so you get an idea about economic modeling from a formal point of view, but for the exam, it's not going to be too important. Okay, so it's just for understanding what's going on, but it's kind of technical. Okay, I try to explain everything as clearly as possible, but it's math. Okay, basically it's math. Okay. So do not get lost. Okay, if you get lost, just let me know. I try to explain everything as carefully as possible. Okay, so now let's start with some definitions. Okay, I'm going to start with some definitions. So basically what we do is we have here a similar model to the Epsilon. It's just much more general. Okay. Okay, so here you have two types of goods. We have Y and Z, two factors of production, and then we have that there is pollution. That would be D. Okay. So K is capital, L is labor, D is pollution, Z is the labor intensive, Y is the capital intensive good, and Y is the polluting good. Okay, Y, Z is the clean good. Okay, now first thing. Okay, so well, again we normalize the price of Z to 1. Okay, that's something, remember, you can always do, because what matters in economics is always relative prices rather than absolute prices. And therefore we will focus on PY, which we call simply P, as mentioned before the break. Now, national accounting. National accounting here, national production, I defined it as a G function, which depends on the price, on K and L and D. Okay? And I'm going to be more formal, okay, about what this looks like, okay? But basically it is intuitively, it is the maximum value for national production that can be achieved prevailing world prices. Okay, and available factors of production and technology. And maximum allowable emissions, okay, if there is a cap, for instance, on emissions. Okay. Therefore, formally, okay, what we have is that national production, okay, is the following. Okay, it is the max, where you maximize choosing Y and Z of PY plus Z, where you take Y and Z from the technology set that depends on K, L, and D. Okay, so my T set here, this is it's something like the production feasibility set we have seen in a previous lecture. Okay, remember the production possibility set we have seen, the production possibility frontier, whatever. Okay, this depends on the technology that's available. So we have seen that this therefore depends on K and L and how K and L can be combined in order to produce a certain output. And the only thing that here is added, it also depends on D. Okay, D here is pollution, and here pollution is dealt with like an input, okay, meaning that in order to be able to produce, you need also emissions. Okay, so emissions is like still treated like an input. Okay, is it clear? So it's but it's clear byproduct. Right? Producing Y, pollute the environment, leads to emission D. Okay, this is how it's here written. The T is my technology set. Okay, as a consequence, here you have that y hat and z hat. These are the maxima, where the values that solve the maximization problem. Okay? And as a consequence, you have also that K hat and L hat and D hat are the corresponding inputs. Okay, so you maximize. I want to go too far away, otherwise at home they can't see. Let me see if I can do this kind of differently. Okay, well, perhaps. Okay, perhaps. Okay, so what you do now? Well, okay, what you want to do is choose y and z, and therefore the solutions of I call these solutions y hat and z hat. And then as a consequence, by choosing y hat and z hat, I also choose k hat and l hat and b hat. Okay? Just by choosing y hat and z hat. Okay, remember, this is also what we've seen in when I solved the Heckscher-Ohlin model, okay, with figures. Okay, remember I have a price, and therefore I choose optimally the output, the structure of the economy. As a consequence, given the optimal technique choice by the firm, I have K and L, and as a consequence, I have also pollution. Okay, so this is exactly what we've done also in the previous version. So nothing new here. And what I can do is I can now use the following. I can use the fact that, so this is basically, this is GDP, okay? So this is GDP. So my G is GDP. This is GDP, okay? Now, if you remember, GDP is also, if you remember from macroeconomics, okay? Now, I don't know how many of you have taken macroeconomics. I hope many. But there are several definitions of how of GDP. So this is one. So the value of final output produced. Okay, this is here the first definition. So the value of final output produced. This is the first. But otherwise, you could also think about it in terms of income generated and distributed in the economy. And that's here the second. You have the different inputs. I have L, K, and D, which is a kind of input, and therefore this is the income that goes to these inputs. Okay, so the first is the labor input, and therefore this is W times L is labor income, R times K hat is capital income, and tau times D hat are tax revenues. Okay, so this is the income distributed. Income generated and distributed in the economy. And this is another definition of GDP. Now, from macroeconomics, you should know, okay, that the two are equivalent descriptions of the same object. It's quite intuitive because value of final output produced, okay, is the value that is created in the economy, and this value is then distributed to the factors of production, which in this case are L, K, and D. Because remember, you consider here D like a factor of production. Okay. Is it clear? Something troubling you? Otherwise, just let me know. And therefore, if I consider a representative consumer, I have I equals G. Okay. This is income generated at the aggregate level, and then this gets distributed to the single consumer. Here I have just one consumer, representative consumer. Therefore, this income generated goes to consumer because the consumer is the owner of the labor, of capital, and also here is the recipient of tax revenues. Okay. Is it clear, the setup? It was just definitions. Now let's try to solve the model. Okay, what I would like here to do is, remember, I would like to study the impact of trade liberalization on welfare. Okay, so remember, I would like to study the impact of trade liberalization on welfare. So first of all, I have to define what welfare there is. Here it's quite simple because I have a representative individual, and therefore I have to look at what happens to the individual if to welfare of this individual if there is a trade liberalization. Okay, because I consider here welfare in terms of utility of the consumer, and this is welfare in this case. So the consumer welfare would be consumer welfare. Okay. Okay, so I have therefore here a representative individual, which is endowed with a utility function. The utility function is the classical one. Okay, so you assume that you have something I perhaps briefly mentioned a couple of lectures ago. So you have a utility function that is concave in the consumption of the single goods. Okay, so if you increase consumption of Y, your utility increases, but at a decreasing rate. This is your utility of Y, Z, and Z0 and D0. So you keep constant Z and D, and you just increase Y, and this is how your utility increases. So utility increases in a concave way. So what you assume here is that you have a positive marginal utility, but a decreasing one. Okay, so I would have to add here that second derivatives are negative. Okay. And then I have the pollution, which is a bad. So I have two goods, Y and Z, which are goods. So meaning that increasing consumption of goods increases your utility in a decreasing way. But then you have also a bad, that is pollution. So increasing pollution decreases your utility. Okay. So nothing new here for, this is perhaps I also mentioned this in past lecture. And then here, therefore, what you do is you maximize your utility, choosing Y and Z, and given your income. Okay, this gives rise to the indifference curves and whatever. Okay, but I'm not going to solve this now with indifference curves, but rather what I'm going to do here is I'm going to solve this with the Lagrangian. Okay, with hopefully you have seen in mathematics. Okay. And therefore I can straightforwardly use the solution we already know. And I'm going to use some properties of the Lagrangian. Perhaps some of these you have seen in mathematics. Okay, so what is the Lagrangian? I'm going to solve the problem using the Lagrangian. So I'm going to set up the Lagrangian function, which is given by the function I would like to maximize, which is my utility function. And then I have lambda, which is the Lagrangian multiplier times the budget constraint. Okay, the budget constraint is I minus the expenditure for goods, so Py minus Z. Okay. So lambda is my Lagrangian multiplier. Everything clear? Can I go fast? Just let me know. Now, what I'm going to do is the following. Okay. I'm going to, first of all, define what my indirect utility here is. So V is my indirect utility. That is, it is the utility at the maximum. Okay, remember, because I choose Y and Z, and therefore I call V the indirect utility. This is the definition of the indirect utility. And since Y, remember, Y and Z hat, they depend on their functions of the price and my income. Because remember, the consumer's choice depend on the price and on the income that it face. The change in the relative price changes the consumer's choice, and as well as a change in income changes the consumer's choice. okay, because of substitution and income effects, okay, if you remember from microeconomics, okay, because of substitution and income effects. So what I can do is now, I can now investigate how the individual's indirect utility function, therefore the individual's in the indirect utility, changes as pollution changes. Okay, as pollution changes, and then also as the price changes. Because remember, what we are going to study here is trade liberalization. We have seen that trade liberalization has a double effect. It affects the price. Trade liberalization affects the price of goods on the one side, and on the other side, it affects pollution. Okay, that's why this is trade liberalization. So trade liberalization affects the price. One side, depending on whether I'm an importer or an exporter, I have either a decline or an increase, as we have seen before the break. And then on the other side, it also affects pollution, depending on whether I'm an exporter or an importer of the dirty good. And then we are going to see how both of these affect my welfare with my indirect utility funds. Okay, this is what we're going to study here. Now, intuitively here, we're going to see this formally. Pollution has a twofold effect on individuals' indirect utility. So the direct effect is that clearly pollution affects negatively individuals' utility because pollution is bad. If I'm living in a more polluted environment, my welfare is lower because of health effects, for instance, asthma or whatever, okay, lower, higher infant mortality, lower life expectancy, okay, and so on and so forth, all these things. But also because of an indirect effect, that is, pollution affects the individual's income. Because pollution affects the production possibilities, and therefore production possibility affect my production choices and therefore my income. And I have to take all these into account. The effect of P, the price on consumer is quite standard. We are going to see these effects in a minute. Okay, but then the novel part here is the effect of pollution. Okay. Okay, any questions from an intuitive? I mean, everything clear till now? Okay, so what I would like to do now is just go over the month. Okay, so therefore what I have to do is I have to take the total differential, taking into account that a change in pollution affects, on the one side, as mentioned, welfare directly. On the other side, it affects income, and income affects welfare. Okay, this is what I just discussed above. Okay, pollution is bad. Pollution is bad. And affects pollution affects income. Okay, here pollution affects income. This is the first effect. Okay, pollution affects your technology set. It would be P affects G, but clearly G is income. Income affects your utility. Therefore, affects income through production. And this is the second part here. So let me repeat this. This is the direct effect. And this is the indirect effect. Is it clear? So you have to sum these both. Okay, pollution directly affects welfare and indirectly through production and therefore income. Okay, sorry, P, okay, this is what P is not pollution, it's price. Yeah, sorry, that's what I said just is for this, okay, it's just the same, okay, because the two is, yeah, sorry, just recognize this now. It's not P, is the price, but I mean, it's the same, okay, it's just, it's, sorry, should have written here, oops, D instead of P, sorry. And the, okay, sorry. Yeah, the choice of, okay, so it's this here, but it's the same. Okay, it's just because the formulas are the same. But also prices affect directly and indirectly. Okay. So therefore, what I said just referred to this here, and I just used the wrong symbol. Okay, sorry for this. Okay, because this second here is the. So is it clear? What I said is correct. It's just referred to the first part, not to the second part. Okay, I just used the wrong symbol. The same happens also for the price, because the price has a direct effect and an indirect effect. Okay, so the price directly affects the utility of consumers. And it indirectly affects the utility of consumers because a change in prices affects production and therefore income. Okay, so let me repeat the second part here. Okay, the second part on price. This is the standard part. Okay, a change in price affects directly consumers because clearly, if the price of goods gets more expensive, okay, then you have a reduction in welfare. Okay. And this is captured by VP. If there's a change in prices, then you have a change in the production structure. A change in the production structure leads to a different income, and the income affects again consumer. This will be the second part. Wrongly referred to before. Clearly, the interpretation is different, but the two effects are similar. They're always direct and indirect. Is it clear? So pollution directly affects welfare because pollution is bad. Pollution affects the production set, therefore production choice, income, and therefore welfare. This is the price effect. The price affects directly utility because it affects it affects welfare directly. But it also affects welfare indirectly because a change in prices affects the choices made on the production side, so what is produced in the economy, and therefore affects the income generated in the economy, and therefore affects utility. Okay. So this is what's from a mathematical point of view called the total differential. So everything that changes here, it can change. Now what we have to do is we have to interpret these derivatives in terms of economics. Okay, so to get economic intuition for what's going on here. Now what we do is we collect, or put differently, we divide both sides by VI. Okay, so that will be the derivative of indirect utility with respect to income. What you get, therefore, is GD plus VD over VI times BD. And then the second term is just GP plus VP over VI times GP. Okay, nothing special here, just divided both sides by VI. Okay. Now, first interpretation here is the following, and that is minus VD over VI is what is called the aggregate marginal environmental damage. VD over VI with a minus in front is what is called the aggregate marginal environmental damage. So this is if you increase by 1 unit the pollution, this is how this is going to affect consumers in terms of welfare. And that's why it's called the aggregate marginal environmental damage. It will be this part here. With a minus in front, because we know that it's always VD is negative. VI is positive, okay, because increasing income increases welfare, but increasing pollution decreases welfare. That's why you have a minus in front. So A and D is positive. Okay, now so over the past years, I experienced that many of you, or many of past students, were not very familiar with the envelope theorem. So I don't know if did you see envelope theorem in mathematics? Okay, it's one of the most important mathematical theorem. That's why I'm going to discuss it very briefly, but I'm going to use it. Okay. So what does it tell you? Okay. I'm going to use it now several times. That's why it's useful to know it. That's for economics, it's one of the most important theorems. Okay, so let's have a function. So this is the formal description of the theorem. It's very simple. Okay, nothing special about it. So assume you have a function here. I'm calling fxa. Okay, so it depends on x, which is my choice variable, and a is a parameter. Okay, x is my choice variable, a is a parameter. Okay. And therefore, what I would like to do is I would like to maximize this function with respect to x, which is my choice variable. As a consequence, what I get is I get, as a result, fa. But that is to say, fa is just f of x hat a, where x hat is the argument of the maximize f with respect to x. Okay, so x hat is my solution. Okay, x hat is my solution to the maximization problem. If I plug x hat in into my function, I get fa, capital Fa. Is it clear? This now the claim of the theorem is the following. The claim of the envelope theorem, very simple, is the following. If you take now that you might be interested in, and indeed in many cases we are interested in how f changes as a changes. So this is the derivative of f with respect to a. Then this is just the derivative of x with respect to a. So that is to say, there is only the direct effect, there is no indirect effect. Okay, because in principle, you might also think that a change in a affects f directly, but then also indirectly to x. But the claim here of the theorem is that this indirect effect is 0 because you are maximizing. Is it clear? So since you are maximizing the indirect effect is 0. I'm going to prove the theorem, because proving the theorem explains you why this happens. Okay, this is a constructive proof. It helps you explain what's going on here. Okay, so here the proof is very simple. Okay, let me write it here. Okay, so in principle, what you have is, if you take the derivative of f with respect to capital F with respect to a, what you have is the following. You have that you have the indirect effect. So that is how a changes. Oh, sorry. Yeah, how a changes x, and then how x changes my function. And then I have the direct effect plus f a. Really, I should not have here hats. Oops, sorry. Okay. Because the derivative is back to x. Okay. This was just to help you. Then I have the direct effect. This is how a affects my s directly. So I have the direct effect and the indirect effect. Now, because of the first order condition for the maximization problem, which is the derivative of f in x hat, the derivative with respect to x, since this is equal to 0, this term here vanishes. And that's how I get the result. Okay, so that is to say, you only have the direct effect and not the indirect effect. Okay, is it clear? This is the envelope theorem. Okay, so I can forget about the indirect effects because I'm maximizing, and this implies that the indirect use of effect is second order. Okay. You don't have first order effects. Okay. Is it clear? Now, why is this useful? Because this is now something I'm going to use here. Okay, let me see. Okay, so this is what I got previously. Okay, just by substituting here, this remember is V D over V I. Okay, otherwise I haven't done anything. Now what you can do is you can do the following. Because of the envelope theorem, because of what I said just right now, you have that GD is tau and GP is y. Now, why is this the case? Remember the definitions I gave before. Okay, so my G was equal to W L hat plus R K hat plus tau D. So therefore, if I take the derivative of G with respect to D, I know that D affects L hat and K hat, but these are, because of the envelope theorem, second order effects. So the only first order effect is the direct effect here. That's how I get that this is equal to tau. Is it clear? Because these here are maximizing, remember, my G choosing L and K. That's why these effects here disappear, and I have only the direct effect. The same happens also for GP. Now remember the definition of G is equal to Py hat and plus Z. It is another definition of G. So here I'm defining GDP, and it is national product, according to the value of final goods produced. And therefore, if I take the derivative of g with respect to y, this is just, sorry, with respect to p, sorry. Oops, with respect to p, this is just y. Okay, this is, some of you might have heard, this is the Hotelling theorem. Okay. The GP is just y. Okay, so I got these two using them. Okay, Z also has clear head. Is it clear? So I'm using here the envelope theorem. So I can therefore substitute these results into my equation here above, and therefore what I get is tau minus, tau is my tax rate, if you remember, minus the aggregate marginal environmental damage. Here I have y plus Vp over Vi. So therefore, the only thing that I have to, okay, by the way, this here is from the production side. Okay, so here, so this, remember, here is from the production side. So this is from the production side because I'm using here the definition of GDP as the value of final output produced. Okay, that's why this is what is produced in the economy. Because now I'm using here some further results concerning Vp or Vi, which are but from the consumer side. Okay. Okay, so the only thing that remains to, sorry, okay, I'm done, okay? The only thing I have to do is now calculate Vp over Vi. It's quite simple because, again, I'm going to use the envelope theorem. Okay, so how can I calculate Vp over Vi? What I have to do is I have to use the Lagrangian. I have to use the Lagrangian because the Lagrangian is the Lagrangian is the value, is the utility value. Okay. In particular, we have that. Oops, we have that. If you consider here L, if I can write this L, Y, Z, and D, which also clearly depends on parameters P and I. Okay, if I do this in the optimal value, then this is exactly my V, P, and I. Okay, my indirect utility. Okay. Okay. So that is to say, the Lagrangian is at the maximum. The maximum is the indirect utility. So therefore, what I mean, if you remember this is perhaps something you have seen in mathematics, hopefully, okay, that if you if this is clear, then the following. So what you can do is, therefore, remember what I have to calculate is I have to calculate the derivative of V with respect to P and the derivative of V with respect to I. So therefore, what I have to do is I have to take the derivative of V with respect to P, but this is just the derivative of L with respect to P. And again, I'm going to use the envelope theorem. Okay, so only the direct effect matters, and therefore this is minus lambda y. Okay, because it enters only here, okay, P. So all others are indirect effects. So it's true that P affects Y, P affects Z, P affects D, but since I'm maximizing over these are all second order effects and not first order effects. And therefore they vanish. And only for the first derivative, only the direct effect matters. But this now, remember, this is now from the consumer side. That's why I'm putting here a C on top of it, because this is from the consumer perspective. So this is Y, the number of the units of Y I would like to consume, while the Y we have seen here above is from the production side. Okay, yeah, the units produced, and they not necessarily coincide because of exports and imports. Okay, and the last thing I have to do is, so this would be this expression here. The last is the derivative of V respect to I, but this is just the derivative of L with respect to I. And this is the lambda. Okay, this is perhaps something you have seen in micro or in mathematics. This lambda is the shadow value of income. The lambda is the shadow value of income. So lambda is intuitive. Lambda is, from a mathematical point of view, it is the Lagrangian multiplier. But from an economic point of view, it is a measure of how much your utility increases if you get an additional unit of income. And therefore, it's the marginal utility of income, the shadow value of income. Okay, let me repeat this. Okay, here, if you follow through the mathematics, it should be quite clear. Okay, because increasing income leads to an increase in utility, and lambda is a measure of by how much your utility increases. So that's why lambda is the marginal utility of income, the shadow value of income. Okay. Okay, now we are ready to calculate V. This is VP over VI. Sorry. V over VI. I just have to now use this. So this would be my VP. This is VI. So if I do this, I get here minus lambda YC over lambda, and that's why I get here minus YC. Okay, if I put all this together, I get this final expression, and this is our final result, and we can interpret this. So we are done. Okay. So remember, this was VP over VI. Yeah, and the others we've already seen about. Okay, now we're ready to interpret finally this result. Okay, this here, so this expression is quite simple. Okay, this is the left-hand side here tells me the change in utility if there is a change in pollution and in prices. Okay, so the change in utility if there is a change in pollution and in prices. So this second part here is gains from trade. I'm going to show you why these are gains from trade in a minute. And this is the effect of pollution on welfare. No, all the effects. All the effects. Here I've taken everything into account. So how pollution directly affects welfare, also indirectly through a change in production technique. The same for the trade, for gains from trade. Also there I have how a change in prices affects utility directly. Okay, if the price increases, we know that utility goes down, but on the other side, we also know that there's a change in production and as a consequence in income, and as a consequence, it affects utility. So both of these. So always we take direct and indirect effects into account. So this is everything that happens in the economy. In a general economic equilibrium framework, okay, taking all the effects into account. Now let's interpret these. Okay, and then I'm going to stop. Okay, so let's start with gains from trade. Let's start with gains from trade. Gains from trade are positive both for importers and exporters. So gains from trade are always positive for importers and exporters. That is to say, this second term here is always positive. This is always positive. So why is this the case? Consider first of all an exporter. For the exporter, so if I'm exporting Y, if I'm exporting Y, then Y is larger than YC because production is larger than consumption of Y. But for the exporter, if there is trade liberalization, the price goes up. And therefore, DP is positive. And so you have positive times positive, which is positive. Okay, let me repeat this. Y with nothing, no superscript, okay, is production. YC is consumption of Y. For the exporter, production is larger than consumption, and therefore Y minus YC is positive. But for the exporter, if there is trade liberalization, the price increases. Because remember, PE in the previous before the break, okay, we have seen that PE for the exporter increases. So that is to say, DP is positive. Okay, therefore, I have positive times positive, which is positive. For the importer, I have that Y minus YC is negative because production is lower than consumption. But for the importer, so this is negative. But for the importer, remember, PM goes down. That's why DP is negative. Therefore, this is negative. Oops. And therefore, negative times negative becomes positive. So this is always positive. That's why these are gains from trade. We always benefit from opening up the trade because of enlarging consumption possibilities. This is what we have seen before. Okay, here you see it from a formal point of view. Both importers and exporters benefit. Now, let's consider the first term, which is due to pollution. Okay, changes in pollution can undermine gains from trade. Now, let's start first of all with the assumption that tau is lower than the aggregate marginal damage to the environment. So you have a relatively lax regulation in place. In this case, what happens? If the country exports Y, then trade liberalization increases Y and therefore pollution. So in this case, the first term is negative. Okay, the first term is negative. Remember, this is tau minus aggregate marginal damage times the D, and then here you had y minus yc dp. This is my dv over vi I actually. Okay, so therefore here what you have is if tau is lower than aggregate marginal damage, then you have that this is negative, but this is positive. Sorry, this is negative. Said negative, and this is positive for the exporter. Therefore, overall, it's negative. Now, the opposite is true if for the importer, because for the importer, what you have is that the first term is still negative, but now the second term is negative as well, because for the importer, pollution goes down. Because remember, for the importer, remember, PM goes down, but this means that production of Y goes down, which means that pollution goes down. So meaning that D is negative. Okay, and therefore I have negative times negative, which becomes positive. Is it clear? And therefore, in the case of the importer, you have a double dividend, which I mean, intuitively, it's quite clear. Previously. Therefore, you have a double dividend. Now you see here the importance of taxes, because the closer taxes are to the aggregate marginal damage, the lower is this effect here. Okay, the closer is aggregate marginal damage to, so the taxes to aggregate marginal damage, the lower is this effect. Indeed, if tau equals aggregate marginal damage, then there is no environmental effect on welfare. Why is this the case? Because remember, what is aggregate marginal damage? This is the damage done to consumers. And why does this lead to welfare loss? Because producers do not take this damage into account, because prices are wrong. So what you can do is, therefore, you can correct it to a price. And this is what you have seen in the first lecture, okay, remember. So if you set tau equal to the marginal damage, you no longer have the externality, and therefore you no longer have environmental damages in utility terms, okay? So this goes back to our first lecture, okay, when we have seen how to set optimally taxes. Okay, here, if the tax rate is set in an optimal way, you have to set it equal to the aggregate marginal damage. In utility terms, this eliminates the externality, and therefore production choices are optimal, and so there is no utility damage. Okay, is it clear? And therefore there are only gains from trade. But on the other side, if there is a lax regulation in place, so the lower tau is, the stronger is this. Last but not least, and then I'm going to stop. What happens if there is a pollution quota? So if there is a pollution quota, in this case, you see what happens is that if there is a pollution quota, then DD is equal to 0. Does not change. Pollution does not change at the aggregate level. And therefore, the first term is always 0, because pollution does not change because of a quota. And so you have only gains from trade. Okay, so this was quite simple. Therefore, pollution does not change with trade liberalization because of the quota. Okay, questions? Okay, then no questions. I would like to stop here. So today I'm running kind of late. Okay, sorry again for this. And so have a nice week, and talk to you if you want next week. Okay, and Tuesday again. And Tuesday we are going to see the empirical part. Okay, in particular, what drives trade flows and how this affects. What drives trade flows and how, therefore, environmental regulation affects trade flows. Okay. This is what we're going to see next week, but from an empirical point of view. Now we have seen it from a theoretical point of view. Now we're going to see empirical studies on this. I'm going to review some papers. Okay, thanks, and have a nice week. Okay, bye-bye, and thank you.
Thanks. Bye.
Bye-bye, thanks.